Good afternoon, everybody. My name is SUSE Betancourt, and this session is tutorial 1204, building a flexible AI infrastructure with SUSE on our Silicon friends. If there are three things that you walk out of today's presentation that I want to leave you with is basically AI is not just generative AI. We've all been dreaming, learning about generative AI, but that's not the only thing. There are other key AI areas that are equally important, and for example, computer vision, signal processing, anomaly detection, and these different AI use cases may have different usages for silicon. The second one that I would say is your requirements, including your use case, and your deployment model. So do you go on-prem? Do you go to the cloud? Do you end up with a hybrid configuration? Will probably drive the design and implementation process. Customers make choices. If you decide to, let's say, take your environment to the cloud, to an extent, you are subject, your building blocks are those provided by your cloud provider. If you do it on-prem, it's basically the building blocks are set by your IT department. So normally this kind of evaluation will happen later in the testing process, but because we're dealing about AI and about choices, your use case and your deployment model will drive some of these decisions. And then once you address your requirements and you have a design and implementation plan in place, you will find several implementation choices provided by our Silicon friends. And that's what we're going to discuss here today. So in terms of the agenda, I'm going to talk a little bit about the AI imperative, the AI and the infrastructure challenges that are with AI, a little bit about SUSE and our Silicon partners, the SUSE software foundations for AI, and then I'm going to jump into optimizing AI workloads with Silicon. And at the end, it's all about the right hardware for the right workload. So in terms of the AI imperative, by 2026, more than 80% of independent software vendors will have embedded generative AI capabilities in their enterprise applications. Data is a fuel for AI. You'll probably hear me say this later, but without a data strategy, you don't have an AI strategy. It is that important. Diverse AI workloads will demand flexible infrastructure, like I mentioned before. Your use case and your decision in terms of implementation model will drive some of those silicon decisions. AI will be a catalyst for innovation. Businesses are leveraging AI to develop new products and services. They're personalizing customer experiences, and that will drive changes in how we build and implement infrastructure behind. And then we have the need for speed and scale, rapid deployment and scale to capitalize on market opportunities. Now, one of the things that we notice is challenges and concerns. There's the concerns of security threats, regulatory compliance, the rapidly changing tools, and the complex infrastructure. To give you an idea, one of the world's largest financial companies outside of the US, it's only deploying open source private AI solutions because they have concerns about potential data leakage or AI attacks that worry them with the software as a service provider. We have one mid-sized financial company in Europe that stated that they had to have a full and prescriptive control over their data. It cannot be used publicly hosted services, even if the data is local, as external sources cannot gain insight into enterprise data. So the bottom line is there are challenges from the security, from the regulatory, and the changing tools, and you need to take these things into account as you try to build that infrastructure for your AI applications. So let's talk about navigating the complexity. So normally with these diagrams, I'm going to start from the bottom up. So the bottom layer, data management, as I said before, your data strategy will drive your AI strategy. AI thrives on data and managing the entire data lifecycle from ingestion and preprocessing to storage, versioning, and security is a major challenge, and you're going to have to plan for that. For example, training a model on a massive data set requires efficient data pipelines that can handle the volume and the velocity of the data that you're ingesting. You have to ensure data quality, and the security is paramount. Again, the value of your data. You have to look at deployment flexibility, and by that I mean your deployment models. You can do on-prem, you can go to the cloud, or you could potentially come up with a hybrid model. Maintaining the consistency and managing these deployments across these diverse environments could be a little bit difficult. So for example, deploying a trained model for inference at the edge might require a different packaging and optimization than something that you're going to deploy in a cloud environment. Then we have the hardware, heterogeneous hardware. So we have the CPUs, GPUs, and FPGAs. We have security considerations, and there we can be looking at things such as infrastructure as code. So for example, how do you provide secure infrastructure as code for an implementation tool to scan infrastructure as code templates, continuously monitoring deployed infrastructure, version control. You need to think then of secure CI/CD pipelines. How do you do pipeline security, dependency management, secrets management, to name a few? You have the data layer, the data encryption, access control, data governance. And then when you look at things like the network security, network segmentation, private endpoints, and potential intrusion detection and prevention. So these are all challenges on the security layer. Then obviously you have to look at the resource optimizations because the AI workloads can be resource intensive. And that in turn could drive some of the compute resource decisions that you're going to make, whether you can do whatever you want to do on a CPU, on a GPU, or in some instances a DPU. I don't know if some of you are familiar with that. A DPU is a data processing unit. So where you're basically, in the past, you probably all remember the word SmartNIC. So think of SmartNIC version 2.0, where more intelligent capabilities have even moved down to the network. Okay. So let me talk a little bit about SUSE and our silicon partners. This is what I usually call the tree of life. So it's a way of explaining the position of our silicon partners and SUSE. Most people tend to disregard the partners, particularly in the silicon space, but I use the analogy of the tree. Your silicon partners are like the root of the tree. They're usually invisible, but without them, the tree will not survive. So, and in this analogy, I see obviously SUSE as the trunk of the tree, where we provide an ecosystem of products, and combined with our silicon providers, we build solutions, and these solutions are made available through IHVs, ISVs, embedded solutions, or through cloud service providers. And yes, we partner with all the major hardware accelerators, Intel, AMD, NVIDIA, and ARM. And when I say ARM, you got to understand that it's the ARM ecosystem. So it could be Ampere Computing, it could be NVIDIA itself that is also providing ARM-based silicon, it could be NXP, it could be TI, etc. You're probably familiar already with the SUSE AI Foundation. You've probably seen this way too many times, probably this week if you've gone to the technology showcase. But what I'm trying to bring here is, as I mentioned before, everything that I plan from an AI perspective, I'm trying to put a layer of security. So basically, for example, one of the things that we do is we have FIPS certification from the operating system to RK2 and Rancher Prime. So if you're looking to build an infrastructure that can support that type of confidential operation, you can rest assured that we have it. You can have then things like NoiVector and stack state, or what we now call observability and security. So for security, think of NoiVector as your Kubernetes runtime firewall. It's not just about scanning the images, it's about continuously monitoring and securing your running containers and network traffic. It's for runtime threat detection, zero trust network segmentation, vulnerability management, and for DevOps integration. And then obviously SUSE observability that provides that comprehensive observability platform for your entire IT stack. With that, I'm going to jump into the meat of the matter. So if you're going to run AI workloads, the right tool for the right job. So based on what we've seen and when we have with conversations with our silicon providers, without naming specific silicon vendor, I see AI being deployed in 3 use cases: CPU, GPU, DPU. So AI on CPU, when do you want to prioritize? When it's cost efficiency, particularly with smaller models or lower inference throughput, memory intensive tasks, that workloads like preprocessing that require large memory bandwidth, real-time deterministic performance, and for software compatibility. Or you may be implementing a solution like, let's say, Intel OpenVINO that may have an affinity towards running on the processors. I took the liberty of putting some examples. So for example, HAI, where you're doing low power consumption with a smaller form factor, and an example use case would be anomaly detection on an IoT sensor. So that would be a use case for AI and CPU. You can try to do that hybrid inference, the balancing between the cost, power, and performance. So if you want to do some level of processing with light inference on local servers because you're doing an edge type deployment, so you want to do some pre-processing before sending the data to the cloud for GPU processing. For some of the cloud native microservices, like for fraud detection using decision trees in e-commerce, or if you're thinking of like a secure enclave for confidential computing with AI inference, like in the healthcare anomaly detection. Then we move to the GPU, which is the accelerated AI. If you're training large, complex, deep learning models like real-time, high-throughput inference, things that are graphics intensive, scientific computing and simulation. So if you're doing, let's say, cloud-level AI inference with dynamic scaling of GPU resources and you're running LLM inference at scale with a CSP, a GPU might be in your future. If you're doing larger on-prem AI clusters where you have dedicated GPU hardware to accelerate AI workloads, let's say you're doing AI-driven fraud detection, that may be another use case for the GPU. Or you can do edge AI inference for high performance for low power consumption. So you may be running a smart surveillance with computer vision. So the other thing to take into account, when I say a GPU, not all GPUs are the same. So you could be running a smaller GPU on the edge. It's still going to offload the workload to the GPU, but not all GPUs are built the same. It depends on the use and function. And then I mentioned the DPU. So the DPU is it's old and it's new. As I mentioned before, the SmartNIC is being long with us, but the idea to put additional computing capabilities, the potentially of putting an operating system on the DPU itself, so you could potentially have a server within a server, at least to me, something relatively new. So if you want to do things like offloading AI networking for real-time inference, for cybersecurity, that would be an example of a DPU use case. If you want to do cloud AI security and you want to encrypt AI model delivery at the DPU level, you can do so. Or you can look at edge AI deployments where you want to reduce the AI latency, like for example in a small smart factory with real-time AI. That would be another example where you can use DPU. So putting it all together, basically think of it as how I would rationalize your AI deployment. The phase one is the usual assessment and planning. You gather your business requirement, your workload analysis. You look at your infrastructure options and you do your evaluation. And obviously, don't forget about the security and compliance, because that may drive some of the decisions in terms of tools. Do your architecture, potentially run a proof of concept, and then come up your implementation plan. And then once you move into the actual deployment, obviously take into considerations with monitoring and management, the AI lifecycle management, and obviously the continuous improvement cycle. Now, you can do it yourself. You can follow recipes. SUSE has recipes. There are others out there as well. One of my engineers, Alex Akaro, he has his own GitHub page where we have done basically some of the do-it-yourself. So there are GitHub pages where you can see examples that we've done with AMD or with NVIDIA or with Intel, but this would be more on the do-it-yourself. Or you can have SUSE do it for you in the form of SUSE AI. So determine your AI models, your accelerators. You can implement your core software infrastructure, the OS, the Kubernetes, and the orchestration management. You have to test your models, again, your core software infrastructure. You will have to implement observability and security. Or you can go with the SUSE AI route where basically SUSE has taken it for you. If you look at the link below with the sample recipes, you can go there. That's a live link. This presentation will be available come Monday at the SUSECon website. So if you go there, you'll see some of the recipes that we have. We have recipes with AMD, with NVIDIA, and with Intel. And if there are any questions on or more interest in some of the recipes, we'd love to hear from you. And then next steps, try to understand your business objectives. Again, your objectives drive your configuration. Educate yourself on what's possible. Playtime with tools, and then perform an implementation based on your requirements. The reason I keep saying educate yourself and playtime with tools, I see a lot of people tend to jump to come up with a AI solution with trying to look for a silver bullet or like there is this already ready to go solution. And again, as I mentioned in the very beginning, it depends on what you're trying to do with AI. If you're looking for generative AI, that's one set of tools and one set of accelerators that will work for you. But if you work in the manufacturing space and computer vision is your thing, that could be a completely different set of approach. Same thing with signal processing, anomaly detection, and these are just the basic use cases. AI is a rather broad field, and again, my parting thought as somebody who's been doing this stuff for a while, it's truly educate yourself on your requirements, educate yourself on what's possible, and play with the tools before you commit yourself to an actual deployment. So with that, thank you for your time.